Okay, so we said that we are going to divide you up into two groups, right? Group 1 and Group 2. Group 1 will be doing density by hand on one day, and then the same day, Group 2 will be working on the density meter. So you will actually be using a piece of equipment in our instrumentation lab to do a certain part of this lab for you. So we're going to talk about the purpose of the density meter and all of the special things that you need to give it attention, because if you don't give the density meter attention, you're going to hurt its feelings, and if you hurt the density meter's feelings, it won't work really well for you at all. So this video is going to concern you if you are part of the density meter group for that particular day. Okay, so depending on the number of people that we have, we will give you a group of maybe 4 to 6 students. And each of you will have one sample to run on the instrument. That's it. Your job's done for the day. The reason that we only want you to run one sample is because it takes some time. It will take me some time to go through how to use the equipment in person when you get to lab. It will take me some time to explain what the instrument's doing. It will take you some time to run all of these samples that you need to run. And by the time that you are finished, it will probably be ready to go. So we do not want you to run all of the samples for each and every person. We want you to work as a group. We want you to inject one sample that you can call your own. And then we want you as a group to sit down and work on your report together. What is the data telling you? So, within your group, you will be turning in a representative report. Okay, so how's this thing going to work? Well, in the previous videos, if you watched them so far, you will know that you will have certain percentage of salt solutions. You will have a 4%, you will have an 8%, you will have a 12%, and you will have a 16%. Each person in the group will choose one of these to run. In addition, you will also have to inject a DI blank. So one person will be injecting water. And on top of that, you will also have an unknown sample that you will have to inject as well in the instrument, because that's the purpose of the lab, to figure out what the concentration of the unknown really is. So if you take a look at the number of samples that we will have 6 in total. If your group has 6 people, everybody gets to inject at least one time. If your group has 4 people, then somebody's going to have to inject more than once. And your group should not have more than 6. If we have more than 6, then we will get you to double dip. And that means one student will inject 8% and another student might inject 8% as a quality check. So we're going to be using the automated density meter in order to do this. Okay, so what's the things about the automated density meter that we need to know? Okay, so the brand of the density meter that we have is called Rudolph. You know, Rudolph the Red-Nosed Reindeer. Yeah, I can't sing, but that was a skit that I loved when I was little. So every time I say Rudolph, it always makes me think of the Red-Nosed Reindeer. So Rudolph Research is the company that produces the density meter that we have. So after today, you begin to work on your resume. You now need to put, I know how to use a Rudolph density meter, and put the model number, and you can even put what you did with it. Because employers are going to be looking at that kind of information. So why not start early and start now? Put the Rudolph Research density meter on your resume. You're going to see it's not that hard to learn. So what does this density meter look like? What's so special about it? What do I need to kind of take away from it? Well, here is Rudolph Research's website. RudolphResearch.com. Simple as that. I would highly encourage you to go to this website and take a look at the instrumentation that they provide. Because not only do we have their density meter, but we also have their polarimeter as well. And hopefully in the future, not this year, maybe next year or the year after, we will have their automated refractometer as well. That's something that we have put on our wish list. It's something that really hasn't came to fruition yet, but hopefully we will get our hands on the refractometers. What I would like for you to do is take some time and just scour the web page, because Rudolph Research Analytical could be a future employer for you, right? You're learning how to use their equipment. You're learning how to clean their equipment. You're learning how to maintain and troubleshoot their equipment. They need people like you to go around to all of these labs and to take a pride and interest in maintaining and servicing their equipment. And they need people that have experience with their equipment already. So if you're a bachelor, or if you don't really have any ties to the area, and you can be on the road and you can be traveling and seeing new people and seeing new labs on a daily basis, these gigs are great. They pay well, they provide your transportation, they put you up in swanky hotels, they give you cell phones, they give you everything under the moon just to go around and service and maintain the equipment for them that their customers are purchasing. Okay, so with the density meter, I just want to hover over the density meter and we'll click the density meter category. And up here at the top, you will see density meters 2911 and 2910. We actually don't have either one of these. These are newer density meters that they have brought out. It's kind of like the newest, latest, greatest model. Think of the calculator, TI-83, TI-84, TI-84 Plus. It all does the same thing. They're just different model numbers. But this is our density meter in a nutshell. This is what you're going to see on our counter. The side of our density meter is made the same way. And if you look, they're injecting the sample through a syringe. So in the lab, we will show you the proper syringes to use, and we will show you where we keep them. You will fill this syringe up with your solution, your 4, your 8, your 12, your 16, your water, or your unknown. You will load it up. Doesn't matter how much, you just load it up. And you put the syringe into a vessel that's right here to the side. It's made perfectly for that syringe. It plugs the syringe in without a problem. You shouldn't have to force it in there. And you slowly inject your sample into the machine. This machine on the screen will actually pull up, and you will see a video feed, live video feed of your sample being injected into the vessel of the instrument. It will magnify it so that you will make sure that you will inject no bubbles in the vessel. Bubbles are bad. For density, they're bad. And the reason is because bubbles take up space, and that space that's not being taken up by your liquid. And the whole purpose of density is to get the mass of the liquid and the space that the liquid takes up. And bubbles are a no-no in the density field. So it magnifies the sample chamber. It makes sure that you do not see any bubbles in the actual instrument. And sometimes we have to overfill it. And when we overfill it, that's the purpose of this jar to the side. So any extra solution will come out of the back end through this tube and down into the waste jar that is here. Okay, so this is the density meter. Once my sample is loaded, this is a touch screen that's showing up here. We press start, and it will begin to measure the density for me. And then in a matter of 1 to 3 minutes, it will beep, and it will make a noise, and it will tell you that it is finished with the density measurement. And the density measurement will show up on the screen right up here at the very top, and this is showing 1.0474 grams per milliliter. And it will also do it multiple times. It will actually measure the density 5 times. And you'll see a little bit of statistical analysis down here at the bottom of that number. We'll talk about those statistics later. We don't really want to mess with that yet. But this is the average density that it took of your liquid sample. And then you will go to print, and it will print you off a nice formal report that you can then use to staple to your lab. So if you're on the website and you want to read a little bit more about them, you can click here and go to the density meter product line, and it will show a website that will take you through a little bit more detail of the density meter itself. It will go through a series of intro videos.
Hello.
It will tell you a little bit about what the density meter is supposed to do and what the density meter is. It goes through the operation, it goes through the uses, and they maybe will go through a little bit more detail than what I am on this video. This is the actual video chamber that it will magnify and show you the sample with. So that's what you're seeing. That's what they're calling the YouTube. So this YouTube, on this YouTube video, will show you the liquid being injected and making sure that there's no bubbles in your sample at all. And if we see bubbles that look like this, then that's bad. We don't want that to happen. We want to sponge those out of there. So we just keep injecting the sample until those go away.
With live on-screen video.
So you can go through and you can watch the video in your own time. It's a 4-minute clip. I'm not going to waste any more of your time about this video. You can do that on your own. It's not a problem. Okay. If I go back to this main screen and I click density meter again, I can see density meter videos. If I click that link, well, certain videos will pop up. And these are just videos of some of their equipment. Some of their equipment is just strictly density meter. They're showing you alternative ways that you can use their density meter. They're showing you extra things or attachments that you can add on to and get additional analysis of. So you can go through and watch these videos at your own pace as well. I'm not going to waste your time here with it either. So keep in mind, these videos are there for you to watch if you need to, and I would highly encourage you to do that before you come into the lab. Think of it as kind of like a pre-lab assignment, right? Okay, so with the Rudolph Research Density Meter, we said that we take 4, 8, 12, 16, DI, and a blank and an unknown. We run a density of each one. So as a group, you will form a calibration curve. You will report a linear regression line. And you will report a correlation coefficient, is what we call that. And that correlation coefficient, if you've watched the previous videos, is the R² number. So just like before with the hand measurements, what we want you to do is create a graph. We want you to plot the data on the graph. We want you to use Excel to draw the best fit line. We want you to report the y equals mx plus b equation, and we want you to report the R² value. Just like here, just like we did with the hand measurements. No difference. You just use the numbers from the instrument now instead of your hand numbers. So you will do this as a group, and the group will turn in one copy of this graph. Make sure that all of the names of the people in the group are up at the very top. I also want to make sure that everyone in the group is satisfied with the work that's done, because your grade is on the line. Don't trust everybody. You're part of a group. You should have input. All 6 people, or however many people that's in your group, should sit down, look at this chart, make sure it makes sense, make sure the chart is completed as it should be completed, and then turn that chart in. Because if you get an 80 on this lab and you're not very happy with that grade, it's no one's fault but yours, because you did not say something in the group. So one group, one copy. This is our instrumentation data. There's no sense in printing it off 6 or 7 times for everybody, right? Especially since you're going to be doing the same thing by hand on your own. And then what we want to show is we want to see if the instrument is better or if your hand measurements are better. So we look at the R² data and we figure out which method gave me a best fit line. And then we take a look at your numbers at the very end as far as percentage goes. And then we figure out which method gave me a better number. Was it my hand measurement or was it the instrumentation method? If you are unsure of how to do this calibration curve, if you're unsure of how to solve this equation or what the purpose of this r-squared value is, then you need to watch the other prep videos, because it will walk you through step by step of how to generate the curve, how to use Excel, the purpose of the equation, and an example of solving for that equation for percentage. Keep in mind these are the same sample. So the sample that you will be using as your unknown in the instrument will also be the same exact unknown as your hand. We want to compare the values to each other. We want to show you if you're better or if the instrument is better. And that's the way that we do it. We use the same exact sample across the board. All right, so that's the story with the density meter. You'll get your hands on it, you'll get the lowdown, you'll see me inject a sample on the first day that you use it, and then we'll turn you loose. And then from that point on, if you ever need to use density again, you are more than welcome to go to the density meter and use that at your own discretion. It's a very easy, simple instrument to use. It's a very simple instrument to master. There's not a lot of things that go on with it. I do want to keep you in mind that this instrument costs around $13,000 to $15,000 on average. So you are going to be using an instrument that's the price of a small vehicle. Doesn't look like that much, but it is once it goes onto the shelf. And depending on the attachments, depending on the alternative ways that we can order that instrument, we see kind of a range of instrumentation price point with the density meters themselves. So keep that in mind. Please do not abuse it. We want to make sure that we maintain it. We want to make sure that it stays clean. We want to make sure that this instrument has its gears running smoothly and efficiently the entire time that we're in the program. So keep that in mind. So have fun with your groups. Don't get into cat fights. Don't get into arguments about what goes on or if someone didn't inject the right way. You learn together as a group. You do this as a group. Do the analysis as a group. Learn how to use Excel as a group. And I think that you will take away from this experience not only hand versus instrumentation measurement, but really how a working lab is supposed to be ran. Because you'll be working with people in the lab. You won't be by yourself. You won't be a poor little solitude lab brat that's in the corner somewhere with its goggles and lab coat on and, you know, breaking free at 5 o'clock because you see some daylight. There's actually some social networking that goes on in a laboratory environment. Have fun. 2-day lab. We'll see you then.